Hello, this is Mr. Collier, and today we're doing some quadratic applications. Okay, so we've got this first problem here. Mrs. Myers wants to put 60 meters of fencing around her rectangular garden. The width of the garden is denoted by x and the length is y. Okay, let's draw a little picture first. The length is y, the width is x. Write an expression for y in terms of x. The reason we're doing that is you need, or you usually want, one variable in your equation so that you can solve for certain things and graph it and stuff like that. So we want y in terms of x so that we just have x here. Okay, and the key is the 60 meters right here. Okay, so if the perimeter is 60 meters, if it's 60 meters all the way around the rectangle, then just this x and y part is going to be half of the rectangle, so that's going to add up to 30. Okay, so if one side is x, we can call the other side 60 minus x. So instead of using y, we can say 60 minus x, because these two numbers have to add up to 30 minus x, because those two numbers have to add up to 30. Okay, so we have y equals 30 minus x. Now write an expression for the area of the garden in terms of x only. So the area is length times width, so that's x times 30 minus x. So now you see why we had to use x instead of y here, so we can have an equation with one variable. And we can simplify this. This is 30x minus x squared. And in the last question, if the area is 200, find the dimensions. So we're going to put in 200 here. 200 equals 30x minus x squared. And I'm going to rearrange so that 0 is on one side. So I'm going to take the 200, bring it over here. We're going to have negative x squared plus 30x minus 200 equals 0. Then I can find, to find the dimensions of the garden, I need to solve this equation and find x. So what I'm going to do is I'm going to get my graphing calculator. I'm going to use polysmalt to solve. So apps polysmalt2 and go to polyroot finder and next, and I'm going to clear that and type in the coefficients here. So it's -1 and 30. And then we have -200, and I'm going to click on solve, and then we have 20 and -10 are our solutions. So there's actually two possibilities for x. You could have x equals 20 or x equals 10. So what happens when we have, look at these rectangles? Well, we have 10 and then 30 minus x gives you 20. So we could have a 20 by 10 rectangle, or if the width is 20, then 30 minus x gives us 10. So it's basically the same rectangle actually. So we could say the dimensions of the rectangle are, or yeah, let's say that dimensions are 10 meter by 20 meters. Okay, the next problem, we have a lawn, rectangular lawn with a path around it, which measures 10 by 8. Okay, all the information is in the diagram here. Write down an expression in terms of x for the area of the path. So that's just the white area here. Okay, the area of the path is all this white space right here. Alright, so one way we can get the area of the path is you can take the area of the entire large rectangle minus the area of the lawn, right, which is 80. This area equals 80 square meters. This length for this big rectangle here, that's going to be, this distance is x, so this is x over here. So this whole distance here is going to be 10 plus 2x, right? This is 10, x, so 10 plus 2x. And the width of this rectangle is 8 plus 2x. Okay, so if we want to find the area of the path, we can do 10 plus 2x times 8 plus 2x minus 80. And let's simplify that. So I'm going to have 80 plus 20x plus 16x plus 4x squared minus 80. I can do a little bit more simplifying as well. That's supposed to be an 80 there. Oh, look, the 80 and the minus 80 cancel. So we get 4x squared plus 36x is the expression for the area. Okay, what is the width of the path when the area is 208? So we just need to put in 208 into our equation for area. So 208 equals 4x squared plus 36x, and I'm going to get 0 on one side here. So bring this over to this side, we get 4x squared plus 36x minus 208. And I'm going to use the GDC to solve that equation. So I'm going to clear these coefficients and type in 4, 36, and negative 208. And solve. And I get negative 13 and 4, but of course we're talking about a length, so it has to be the positive number. So x equals 4 is the value of x. And okay, that's the answer. That's the width of the path. So the width of the path is 4 meters. Okay, one more example. The number of bacteria N in a culture T minutes after the start of an experiment is given by this equation. Determine the number of bacteria present at the start of the experiment. So at the start of the experiment, that's T equals 0. So we're just substituting in 0. And actually this will give you the y-intercept, which is the initial value of the number of bacteria. So it actually equals 150, which is the constant here. So there's 150 bacteria. I don't know, yeah, number of 150 bacteria in the culture at the beginning. So part B, find the number of bacteria present after 5 minutes. So we're going to substitute in 5 here. Okay, and we'll see what we get when we type that into the calculator. Okay, quit, and we get 150 plus 69 times 5 plus 3 times 5 squared gives us 570. 570 bacteria. Okay, part C, find the time required for the number of bacteria to reach 2000. So they give you the number of bacteria, so that's your n value. So 2000 equals 150 plus 69t plus 3t squared. So we need to solve for t here. So we need to solve the quadratic, and we need to get 0 on one side here. So this is coming to this side. 0 equals, so we're going to subtract 2000. And that's going to be negative 1850 plus 69t plus 3t squared. Let's go to the graphing calculator. I'm going to go to polysmalt 2, poly root finder, and be careful here. We have to type them in the correct order. We need the coefficient of x squared first, so it's going to be 3, then 69, then negative 1850. So 3, 69, negative 1850, and solve. So here we have fractions. We can click on this button here to get a decimal value, and we get, so obviously it's not going to be the negative answer. We have to take the positive answer here, so it's going to be about 15.9 seconds if we round it to 3 significant figures. So t approximately equals 15.9 seconds. So you can say it takes about 15.9 seconds for the bacteria to reach 2000. Okay, part D, sketch the graph of n versus t for 0 is less than or equal to t is less than or equal to 25. So we're going to do that on the graphing calculator. Let's type in the function first under y equals. So under y equals, I'm going to type in the equation here. So we have 3 t squared, so 3x squared is what I'm going to use, plus 69 t plus 150. And then my window tells you to go from t from 0 to 25, so I've put my x values to go like that. And the y values, I've already seen the y value gets up to like 2,000 after 16 seconds, so I'm going to go to 5,000 and see if that works. So I'm going to graph it, and it kind of looks like that there. Actually, yeah, that's good. So we're going to sketch the graph of that right now. So I'm going to, actually, let me use this trace function here to get a look at what the value is way up here on this end of the graph. So it gets to 3,000. The y value is going up to about 3,500 maybe. 3,500, 3,600. Okay, so or maybe even 3,700. So I'm gonna make a little sketch here now. Okay, so this is time in minutes, and this is number of bacteria. This goes up to 25. I'll go up 5s. 5, 10, 15, 20, 25, and it goes up to I said 3,600, so I don't know, something like that. 1,000, 2,000, 3,000. You can be a lot neater with graph paper, and it looks like it goes up something like that.